Hi everyone, happy week 3 of online learning. I wanted to just talk to you a little bit about some information I hope that you had gotten from lessons 4 and 5 of the Serengeti unit, and then give you some information to prepare you for lessons 6 and 7 as they're a little bit harder. Um, the first thing that we were investigating in lesson 4 was if there was a change in a predator population that caused the change in the buffalo population. So remember that we're trying to figure out what caused the African buffalo population in the Serengeti to grow so much in such a short period of time. So in previous lessons, we figured out that it wasn't a change in food availability. They didn't have a whole bunch more food than they did before, which could have caused the population to grow. It wasn't a change in climate that caused the population to grow. So our next step is to figure out if maybe a predator population changed. So we figure out early on in lesson 4 that the primary predators for the African buffalo are lions. And you're introduced to this idea of the 10% rule and like trophic pyramids and stuff like that. So I wanted to kind of clarify some of that because a few of you struggled with that. So when we represent an ecosystem, we can draw food chains food chains really in the shape of a pyramid. And each layer of that pyramid represents the organisms that exist in that trophic level. So a trophic level is just like a group of organisms in an ecosystem that basically get their energy the same way. So in the majority of ecosystems, we have primary producers that are at the bottom of the trophic pyramid. And as you can see, this is a pyramid because the largest group is at the bottom. So primary producers are organisms that basically make biomass. And the way that that works is through photosynthesis. So primary producers are plants. Primary producers harness sunlight energy and turn that into biomass, which seems like magic to me sometimes. And then our next level in our pyramid are primary consumers. Primary consumers are things that eat primary producers. So primary consumers are herbivores. In our ecosystem that we've been talking about, primary consumers are going to be things like the African buffalo. We also talked about Thompson's gazelle and wildebeest. Those are also primary consumers because they eat the primary producers. Then we have secondary consumers. In our ecosystem, we don't really have 4 levels when we're talking about the Serengeti, when we're talking about this specific food chain of lions, buffalo, and the plants, the grass that the buffalo eat. So secondary consumers eat primary consumers, and then most food chains end, or some food chains end with tertiary consumers. So tertiary consumers eat secondary consumers. So I think of an example of this in the ocean where we have primary producers are going to be algae and other photosynthetic microorganisms. And then primary consumers could be like small fish. And then if a bigger fish ate a smaller fish, then the bigger fish would be a secondary consumer. And then like a shark or a dolphin or a killer whale would be considered a tertiary consumer. That's the 3rd level. So tertiary consumers are top predators in their ecosystems. And a couple of things that I want you to notice about this are, again, as we go up a pyramid, the relative size of each of those layers gets smaller. And that's because of the 10% rule, which many of you correctly identified in your exit ticket. So the reason this is a pyramid is because 90% of the energy that existed in this trophic level is lost to heat and other biological processes, but it basically can't be used or isn't converted into new biomass. So 90% of the energy that's here doesn't get transferred to this level. That means that only 10% of the energy gets transferred to this level. And then 10% of that energy gets transferred here, and then 10% of that energy gets transferred here. So as you can see, as we go up each level in a pyramid, we have 10% of the energy going with us and 90% of it is lost. And So this is what dictates the population sizes of tertiary and secondary consumers. When we look at ecosystems, the largest area of biomass is going to be found in primary producers, and the smallest amount of biomass is going to be found in tertiary consumers. So we can see a lot more plants than we would see lions, basically. Another one of the things that some of you pointed out in your answers to the questions was about decomposers. So decomposers are things like bacteria and fungi that exist in ecosystems, and their job is to basically break down all of these things. So when plants die, they get broken down by decomposers. When buffalo die, when lions die, they get broken down by decomposers. And that energy can get recycled back into the ecosystem and brought back in through primary producers, through plants. So again, 10% rule says that only 10% of the energy in a trophic level can get passed to the next level. And then these are examples of the trophic levels, or the terms that we use for trophic levels in an ecosystem. So one of the things that we asked you to do in lesson 4 was some calculations. So if we know that the lion population has to be, only 10% of the energy in the buffalo gets passed on to the lion population, then what does that look like for the population size of the lions? Meaning, how many buffalo could support a population of lions? Or how many lions could the buffalo population support at its smallest population size and at its largest population size? And so as we went through those calculations, which you can find on the last, or one of the last slides in the slide document, we see that the highest population of buffalo was 80,000, and the lowest population was about 30,000. So what that means for if a buffalo is 40 or 400 kilograms, then we can see that 80,000 buffalo times 400 kilograms equals 32 million kilograms. That's representing the highest biomass of buffalo that exists at the buffalo's highest population on that graph. And then we do the same thing for the lowest buffalo population, and we see that that's about 12 million kilograms. So then we ask ourselves, okay, if 10% of that can get transferred to the lion population, then that means that 3.2 million kilograms of biomass can get transferred from the buffalo to the lions at the highest population, and 1.2 million can get transferred to the to the lion population at the lowest buffalo population. Sorry, that was confusing. So basically, we're just figuring out like how many lions can this population of buffalo healthily support. And it turns out that the lowest population of buffalo could support about 7,500 lions, and the highest could support about 20,000 lions. And so what you did after you got those numbers is you should have looked at the lion population graph and seen that the lion population was really only between 100 and 300 lions in the Serengeti, which indicates that the lions were not at their highest population at any point in order they had, really what we're getting at is that there was more than enough buffalo food to support the lion population, but that the lion population was so much lower. And many of you correctly identified the reason behind that as that lions don't only eat buffalo. And the lion population stayed pretty low and fluctuated a little bit, but there wasn't a clear pattern to indicate a causal relationship between the lion population and the African buffalo population. So all that was really to say that only 10% of energy gets passed on from the buffalo to the lions, and that the lion population didn't have a significant impact on the buffalo population, meaning that it's not a predator factor that caused the buffalo population to increase. So we can kind of cross that off our list of not the causes. So that brings us to lesson 5, which is about a disease called rinderpest. And this is one of my favorite lessons for so many reasons. But basically, you should have read the excerpt from the New York Times article and figured out that there was a disease that commonly affected cattle, and there was some domesticated cattle in the area in the early 1900s and 1800s as well. And these cattle were commonly afflicted with a disease called rinderpest, which was a nasty virus that you read about that was really gross. And scientists were able to develop a vaccination for rinderpest so that the cattle weren't dying, and people that, were, their livelihood was raising cattle for meat or milk or whatever, their cows weren't dying, basically. And so a vaccination was developed for rinderpest, and the vaccination of cattle was conducted, mass vaccination was conducted of cattle in the 1940s. So what does this have to do with the buffalo and the Serengeti? So we have the vaccination of cattle in the 1940s, and rinderpest is what we call a spillover disease, meaning that the rinderpest was typically found in cattle, but because of the way that that virus was spread, it was spread to buffalo and wildebeest and other similar organisms in the Serengeti that live nearby. So the buffalo and wildebeest of the Serengeti were also hugely impacted by rinderpest, and their population sizes were kept very low because of this disease. So in the 1940s, the vaccination of cattle against rinderpest occurred, and so what that meant is that now cows aren't getting rinderpest anymore. If they're not getting rinderpest, then the cattle population can't serve as a reservoir for this virus, meaning that the virus doesn't exist in high enough amounts in the cattle population, so then it doesn't spill over into the wildebeest or the buffalo population. So we get the vaccination of cattle, and that caused the elimination of rinderpest in cattle, but also in the wildebeest and the buffalo populations. So, and rinderpest is one of two diseases on planet Earth that scientists can claim to have eradicated, meaning that things don't die from rinderpest anymore, and that is essentially 100% due to the fact that we vaccinated the cattle. So rinderpest is one of two pathogens on planet Earth that have been completely eradicated. The other one is smallpox, which maybe you've heard of. Smallpox doesn't occur in humans anymore, or in anything anymore, because of vaccinations. So thanks, vaccines. So we get the elimination of rinderpest in the cattle, and then it can't spill over into the wildebeest and the buffalo. And so what we get is a huge population growth in the wildebeest and the African buffalo. So we figured out what caused the population of buffalo to increase so much from 1960 to 1975. So I'm trying to draw some images for you. So we have the vaccination of cattle against rinderpest, results in the elimination of rinderpest, which results in no more rinderpest in the Serengeti, so the wildebeest and the buffalo populations increase drastically after that. So the reason that our buffalo population grew so much from 1960 to 1975 is because a disease was eliminated from their ecosystem. Did any of you predict that? The scientists that studied this ecosystem did not predict that. It was a very big deal when they discovered that this was the cause of this African buffalo population increase. And so One connection to make is that the novel coronavirus that we're dealing with right now, that's just changed our world, is also a spillover virus, meaning that we got this virus from something that was not a human. And scientists are still really trying to figure out what that was. Occasionally, viruses can spill over from one population to the next, and that's kind of what we're experiencing right now. So, you guys, we figured it out. We figured out that the buffalo population increased from 1960 to 1975. So, wow. Let's pat ourselves on the back for really doing some great science. Lessons 6 and 7 are this week. And lesson 6 is about what happened to other organisms on the Serengeti. So we've mentioned throughout that there are wildebeest, and wildebeest migrate and compete with buffalo for food and are also a food source for lions. And so we're going to use some data and look at the effect of all of this on the wildebeest as well. Some of you asked when we built our driving questions board about like what else is happening to other things on the Serengeti or in this ecosystem during this time. And so we are going to look at that, and we're going to start primarily with wildebeest. So lesson 6 is about what's going on with the wildebeest, which are very closely related in a lot of ways to the African buffalo, as you'll see in this lesson. And then lesson 7 is a computer simulation. So this is hard. Lesson 6 and 7 are both significantly more involved than the previous lessons we've done on remote learning. So I want to give you some time, like make sure you give yourself time to really work through that. And know going into these lessons that they are going to be a lot more time consuming than lessons 4 and 5. A couple of you in your student activity sheets made, like when you were answering questions, you said, I don't know this. I don't understand this. Miss, I have so many questions. To which I respond, hello, ask for help. I'm literally just sitting here waiting for you guys to email me with questions or to show up at office hours. If you can't show up at those office hours or you want to do like a one-on-one video session, that's fine. I would love to help you. I know that this feels like you're supposed to be figuring everything out on your own, and that's not really true. I'm still here to help you, and I still want to explain things and talk things through with you. But I need you to reach out when you have questions. Email me, text me, send me a message on Schoology. Show up to office hours, or email me and set up a time that we can do a video chat one-on-one. Literally any of those ideas are great, but just saying, Miss, I don't know, and then turning in an incomplete assignment isn't going to work out for you. For each of our lessons, we only have 2 things, our student activity sheet and our exit ticket. And many of you have seen that if you don't complete the student activity sheet, I give you an incomplete on it, and I send it back to you with some comments. So please reach out if you have questions, if you don't understand. I don't expect everyone to pick up everything that I share with you and make sense of everything without me. Sorry, Luna's barking. So please reach out if you need help. I look forward to hearing from you soon.